Welcome to EDU World Space.
I'm going to walk you through the steps on how to reduce the two matrices and then use a calculator for part B just so it doesn't get too redundant for you. Well, starting with 1, 4, 5, 8. So the goal is to get it to be the 2 by 2 identity. And so you can do something like take row 2 and subtract 5 times row 1 because you want to get a 0 under the 1 to get, your goal is to get 1, 0, 0, 1. And so if we take row 2, subtract 5 times row 1, we'll get 5 minus 5, which is 0, and 8 minus 20, which is negative 12. Now taking this matrix, let's get a 1 in this position by taking negative 1/12 of that row. That gives us 0, 1, and 1, 4 stays the same. Okay, now we just need to get a 0 here, and we can do it by taking row 1 and subtracting 4 times row 2, because then we get 4 minus 4, which is 0. And now we have 1, 0, 0, 1. In the second matrix, the 3, 1, 2, 1, 2, 5, 4, 0, 1, we want to get this to the 3 by 3 identity, 1, 0, 0, 0, 1, 0, 0, 0, 1. Other things you can do, I'm only using this to illustrate, you can swap rows too, so I'm just swapping rows 1 and 2. So it becomes 1, 2, 5, 3, 1, 2. And now we notice we have a diagonal of 1s at the moment, but we have to get 0s here below the 1. So we could take row 2 and subtract 3 times row 1. So that would be 3 minus 3, which is 0, 1 minus 6, which is negative 5, and 2 minus 15, which is negative 13. Okay, so we got a 0. We can get a 0 here underneath by taking row 3 and subtracting 4 times row 1. Then we get 4 minus 4, which is 0, 0 minus 8, which is negative 8, 1 minus 20, which is negative 19. Then we can take, get a 1 in row 2 by scaling row 2 by negative 1/5. Negative 1/5 times negative 5 is positive 1, and then it's positive 13/5. Rows 1 and 3 stay the same. Okay, now we want 0s above and below that. Starting with below, we can take row 3 and add 8 times row 2 to it. That'll create a 0 here. We'll get 0, 0, and then negative 19 plus 8 times 13/5 is 9/5. Pause if you need to. And then we can get a 1 in row 3 by taking 5/9 of the row. That just turns it to 0, 0, 1. Now we need 0s above and below, starting with in row 1, column 2. We can achieve that by doing row 1 minus 2 times row 2, because then we have 2 minus 2 is 0, 5 minus 2 times 13/5 is negative 1/5. Okay, then we can get a 0 in row 1, column 3 by taking row 1 and adding 1/5 of row 3 to it. Then we'd get a 0. And our last 0 is needed here. We can achieve that by taking row 2 and just subtracting 13/5 of row 3. Then 13/5 minus 13/5 is 0, and we've got our 3 by 3 identity. So now I'm going to show you how to use a calculator. I'm going to use the Desmos matrix calculator. I'm not sure if you're able to use a calculator. If not, then you would just do the row operations that we were just doing on these two, but you're going to augment. You're going to have the coefficients 2, negative 5 augmented with the constant 0. So it's 2x negative 5y equals 0 and 4x plus 3y equals 0. Once it's stored, then you want to find on your calculator the reduced row echelon form, RREF, of that matrix. And we get 1, 0, 0, 1 equals 0, 0. So what this means is that, I'm going to pause for a moment. So when we get this result, what that means is that x is 0 and y is 0, and that would be the solution to the system that you could confirm is true in both cases. Okay, so now the second one, I'm going to do another new matrix. This would be 3 rows and 4 columns. The first equation was 1x plus 1y plus 2z equals 1. The second equation, 3x minus 2y minus 4z equals -7. And the third equation, 2x minus 1y minus 2z equals 2. Once it's stored, do the row operations. That's reduced row echelon form is what that's technically called. And we get the following. This would mean that since z, there is no 1 here, we cannot get this in a reduced row echelon form. We cannot get the 3x3 identity matrix on the left, that there is no solution for the second situation. Hopefully this helps you out. Good luck.